Hello, how are you guys? Welcome to this webinar session. My name is Haimo Liu, and I'm a product manager on the Alibaba Cloud team, really responsible for the globalization strategy for a couple of analytical products, and that includes the new product we're trying to introduce today, that is Data Lake Analytics. So just a little bit of a background about myself. Before I came to join the Alibaba team, I was a product manager at Hortonworks, and I was incubating the data flow platform, right? Essentially to drive data from all kinds of devices, switches and routers and airplanes and moving vehicles, from anything into a big data lake. Now at Alibaba, we're trying to think from another perspective, from a consumer perspective. Once I got all the data in the big data lake, how can I turn those data into human consumable insights in an easy and a quick manner? So with me, we have Yolanda, who represents the engineering team, and we're going to give you guys an introduction for this new product. Before we jump into the introduction, I'll let Yolanda quickly introduce himself.
Hello everybody, I'm Junliang from OLAP development team, and I have been working in Alibaba for more than 5 years. And previously, I was the co-developer of the Analytic DB products. Currently, I'm the engineering team leader for the Data Lake Analytics.
Okay, thanks, Yolanda. We'll jump into the topic and introduce DLA for you guys. Here's a very brief agenda just to give a framing for this conversation. We'll start from answering the why question, right? From a user perspective, why would you even care about this new product, DLA? Followed by what exactly is DLA, the definition, and some details. And followed by how DLA can help you solve your problems in the enterprise context. And after all that, I'll give it back to Yolanda to do a technical deep dive, which is really a fine-grained explanation from architecture perspective, give you a little bit of insights for security, for isolation, for all those technical details in conjunction with the cloud infrastructure. And in the end, we'll try to end this talk with a couple of demos for you guys to see how DLA works in real time. Now, let's just start from the why question. There's always a why question. Even though sometimes something is very obvious, it doesn't probably make sense to even ask the why question. But when you think carefully, there's always a why. So just give you guys a quick example. I was talking to Julian the other day, and he just got this kind of new pair of glasses. And I was asking why you got this glass. And he gave me this weird look, and he might be thinking that I'm crazy. So he said, well, because my eyes are aged, so I need to see things clearly, so I got this new glass. So it's a very trivial answer. There's almost no need to ask why. And I just keep going. So why, a framed glass? Why not a contact? He thought about it for a few seconds, and he goes, well, because the framed glass makes me look knowledgeable, and I want this professional looking. And again, I keep going and asking, now why this particular framed glass? Why not another style, another color, just another glass? So after another moment, he said, because there was a promotion going on for that particular glass, right? So with that example, from the very simple conversation, we went down 3 whys, and I found out that as a glass customer, in addition to seeing things clearly, now Julian also cares about the promotional price, and he cares about the professional looking. So as you can see, there's always whys, right? A couple of whys behind his actions. So knowing that, right, we want to give you guys a introduction about why we are even designing and introducing DLA to the users. Let me start by sharing some observations, and you can take those observations as the status quo before DLA was introduced. Our first observation was there was a lot of data available in the Alibaba Cloud, right? Especially in the object storage. And data is available in all kinds of different formats, in CSV format, in Parquet format, in org format, in Avro format, and there's a whole bunch of logs. And there's also a whole bunch of non-structured PDF data such as the invoice data, such as the receipts, so on and so forth. Another observation was previously people selectively save their data, right? They don't save everything. But nowadays, there's a trend because storage is getting cheaper and cheaper, so people tend to save everything, right? So let's take log data as an example. Even though in your log data, maybe 99% are just trash, but we still have a customer who told us they tend to keep 18 months worth of logs just in case they might want to come back after 18 months to dig into those logs and see if there's any valuable information, right? So they just save everything in the storage. It's not optional in the modern data analytics, right? In modern dashboards and reports. Now, based on that, we have a fairly good understanding of the status quo, and we started reaching out to our customers to further understand what exactly they want, right? And how they like to change the status quo. And we got these following answers from our customers. One customer was telling us, I got data with a different size and different formats in the cloud. Like I said before, Alibaba OSS, table store, RDS, which is our relational database, RDBMS. So from a user perspective, I like to run interactive queries against all of my data, but I don't want to run a complex, I don't want to go through a complex ETL process. It takes a lot of time and efforts. I just want to run queries quickly. And another customer was telling us that I only run queries infrequently, meaning that I don't want to pay for a long-running cluster. It's just a lot of work. I don't want to pay for any upfront cost before I run any queries. Another customer was saying that the business requires analytics on new data points with a very short notice. So I don't even have any time to set up a conventional data platform. So I want to quickly get the insights and get the results back. Another example being the business recently introduced a new data source. So I like to do some quick and simple data exploration, right? How can I do that without, again, having to spin up a cluster, having to pay for that cluster and all that kind of stuff. Another example being I like to run analytics across multiple data sources to get the joint insights. Those are the high-level ones. Now let's go one step further to try to categorize the customer wants by user personas and see if there's any additional insights we can get from those users. As an example, Yolanda is a business analyst. And as a business analyst, she creates a couple of BI reports and dashboards every week. For Yolanda, she told us like she doesn't want to run tons of queries every day. It's just not required by her job. Because of that, what is the most convenient and the most cost-efficient way to run queries? Another pain point she has was in order to save some space for a data warehouse solution, she tends to dump the code data into object storage as a regular backup. Now, after she saves like a bunch of data in OSS, how can she get insights from her code data occasionally without having to import that data back to her data warehouse, right? If she needs to import data or move data back and forth between these two different options, object store and data warehouse, it's again a lot of work. And another pain point she has was she's got the transactional data stored in our DBMS, she's got the key value pairs stored in table store and some object data, the code data stored in OSS, and she wants to acquire some joint insights across all of these different data options and stores, right? And how can she do that? Another example being the business is in a hurry to get reports on some new data points, and there is simply not enough time left for Yolanda to set up a conventional data platform. So because of all these points, she starts kind of talking to us and see what kind of service and what kind of product we can make to solve those problems. Another user persona is a data scientist. So for example, Jeremy, he's a data scientist and he owns the end-to-end analytics for his company. He's got a couple of pain points. For example, sometimes he wants to do a very basic data profiling quickly to understand if his data looks valid. So for example, maybe he wants to see the mean value, the max value of a given column, If the value goes from 1 to 20, that means the data set looks valid. But if the value goes from 19 to 19.5, it's just not valid. Another example may be he wants to get the largest string in a given bar chart column and to compare that with his expectation, and so on and so forth. As a data scientist, we all know that he needs to create machine learning models. And in that process, he needs to go through a couple of steps. Number one, he needs to upload training data sets to an object storage such as OSS. And number two, once his data is uploaded, he might want to run some ad hoc SQL queries to interactively explore his training data sets to understand if the data sets are valid. And after that, he needs to go through the training process, the testing process, getting the predictions and saving the prediction results to another place such as RDS. And now he ends up saving data in many different places, in OSS, in RDS, and he wants to get the joint analytic results across all of these different storage options. The OSS, RDS, maybe table store, so on and so forth. Now in that example, he can leverage DLA in step number 2 and also step number 4, right, to run ad hoc queries to explore the training data set and in the end to get the joint analytical results across multiple storage options. Knowing the customer wants, we went from the diverge process where we actually explored the different customer wants to go through a converge process to truly identify the customer needs. And we were able to narrow down to these 5 dimensions. Number one is connectivity. I wanted to be able to connect to all these different sources, the files, the objects, the RDBMS tables, and for data available in different formats, in Avro, in CSV, in org, in Parquet, whatever that is. So think of a consumer and a producer model. The consumers want it to be decoupled from the producers. So producers, they can save a whole bunch of data in different formats into the big data lake. Now from a consumer perspective, they just want to directly query data stored in the big data lake in different formats, data stored in different places, and they want to run they want to have a unified interface to be able to query all of those data available in different places. The second dimension is a serverless architecture, right? So from a user perspective, I want 0 cluster maintenance effort. So if you are familiar with the object-oriented programming language, right? You call an API, you send it a bunch of parameters, and you got the results back. You don't need to know how the object works, right? And how the underlying things working within that object. So this is the same exact architecture. You send a whole bunch of queries to DLA, and you get the results back from DLA. You don't need to know how things are working behind the scenes. And you don't need to worry about the cluster, the maintenance, the upgrades, and all that kind of stuff. The third dimension is I want to run queries quickly without having to prepare my data. I do not want to go through a complex ETL process. Talking to our customers, one of our customers told us that they spend a lot of money on the consultants, IT professionals, but all these consultants, they ended up spending over 90% of their time just working on the ETL script, just working on the plumbing work, not truly focused on the analytical efforts, right? So they don't want that. They want to get the results without having to go through the data preparation process. Another dimension is performance, right? I want to finish my highly concurrent SQL queries within seconds, right? So maybe imagine that as an e-commerce customer, you have this platform that connects billions of individual buyers to like millions of individual sellers, right? How can you enable all those different sellers to run queries against your backend? And all of those sellers, they expect the results back in a couple of seconds. And the last dimension is cost. And this really goes in conjunction with our serverless architecture. Because we can offer the serverless architecture, we are able to allow our customers, our users, to only pay for what you actually use. You don't have to pay for maintaining the cluster. And to summarize, here comes the 5 true customer needs along the 5 dimensions: the connectivity, the serverless architecture, the built-in ETL, the performance, and the cost efficiency. Now, here's a mental picture that I built for myself to truly understand what is a DLA. If you look at it, the whole analytics stack can be described in 3 abstract layers. On the top layer, there's visualization. There's a bunch of visualization products, Quick BI, Data V available in Alibaba Cloud, plus some other SQL clients and some other BI products. In the middle layer, that's where DLA lives, right? So DLA can be connected to all these different visualization products on the top layer, and also all the different storage options on the bottom layer. Think of OSS, think of a table store, think of RDBMS, think of a NoSQL database, and all that kind of stuff. So with DLA, it's hosted as a service, meaning that you as a user, you don't have to worry about any maintenance effort, any maintenance cost. So that's how, as a service provider, we envision to provide decoupled services in these different layers. So on the other side of the house, you as a user, you can select what's the best based on your actual use cases. It could be a combination of, for example, less expensive storage, some less expensive analytical engines such as DLA, and some really expensive but very comprehensive visualization products. It truly depends on where you want to invest your money. Well, the point is, by offering the decoupled services in the 3 different layers, visualizations versus analytics versus storage, the choice is ultimately yours, because we believe only you know what's best for your business. So to summarize, with the DLA, we are able to provide a combination of cost-efficient cloud-native storage plus a very cost-efficient analytical solution. Because you as a user, you don't have to own any processing clusters. You only pay for what you actually use. And on top of cost efficiency, you're also enabled to do interactive queries, right? You just send the queries to the DLA backend and then just get the results back. And not only just one query, but it could be highly concurrent, many queries, and you can get results back for all those queries in a matter of seconds. So that is the key value proposition I wanted to highlight for DLA. Moving forward, let me share some information we collected from our early adopters in terms of how DLA can help in the business context. So let me share some customer success stories. Working with our early adopters, since we started the beta testing process a few weeks back, we were able to identify the following common scenarios. So from a user perspective, some users, they simply upload a bunch of raw data that in terms of logs, right, CSV data, JSON data, Avro data into OSS. They run DLA on top of OSS and they connect the DLA to any selected BI products. Some other customers, they prefer a performance optimized data format. So think of Parquet, think of Org, think of Avro, so they can do the format conversion offline, transforming their logs, their CSVs and JSONs into the performance optimized data format, and they upload those formats into OSS, and in a very similar manner, they can run DLA on top of OSS and connect the DLA to select the BI products. And some other customers, they actually do both in the cloud directly. They can upload the raw data, right, the logs, CSVs, and JSONs into OSS, and they can leverage either DLA or MapReduce to do the format conversion, right, moving those files into the format specific, the performance optimized data format, and then store those data again on OSS. And after that, they can run DLA on top of OSS and connect again to the BI product to get the real-time insights. Now here comes a true customer story. One of our customers, who is an e-commerce platform company, they offer the platform to connect individual sellers and individual buyers. During the National Sales Day in China, which is November 11th, just a couple of days ago, all those sellers on that platform, they tend to run a bunch of queries against the backend to truly enable things like a precise marketing, things like intelligent inventory management. For all the sellers combined together, on average, they scan about 200 megabyte to 1 terabyte of data per query, and they issue a lot of queries, roughly about 200,000 queries per week, and that's a lot of calculations. And they're using about 100 plus analytical functions within those 200,000 queries on a weekly basis. This company, they select DLA because we were able to provide quick insights on their transactional data without having to go through the lengthy ETL process. Right? The key point is all the individual sellers, they know nothing about ETL. Right? There's no ETL engineers working for those sellers. They just want to simply run some very quick queries using a graphical user interface, and they expect results back in a matter of seconds, even milliseconds. So the lengthy ETL process has to be part of the backend engine and needs to be 100% transparent to the end users. And that's why this e-commerce customer selected DLA as a service. Another example is a company providing genomics data analysis to their customers, their consumers. So typically, for a company like that, they go through a data preparation process using a proprietary solution. And afterwards, they take the output of that process and upload those data into Alibaba Cloud, right? Specifically, the object storage OSS. And in OSS, they use a functionality called OSS Select in order to do some simple searching, in order to do some simple filtering functions. Now with DLA, they can run complex queries on top of OSS Select to join their genomics data with data coming from other sources, such as demographic data, right? Such as data coming from some other public data sets in order to get some joint results. With that, as a genomics company who didn't have a lot of analytical capabilities before migrating to the Alibaba Cloud, they can now unleash the power of analytics and provide those as a service to their customers, right? Make the analytical power accessible to their consumers and customers. So that was a bird's eye view of all the things you need to know about DLA from a product perspective. Let me stop here for a moment and give it to Yolanda, our engineering lead, to do a technical deeper dive in order to bring the conversation to a different level.
Okay, thank you, Haimo. So first of all, DLA is a pure cloud-native deployed products on public Alibaba clouds. Each region shares the same deployment architecture. So the components are divided into two groups. The first one is in Cloud Management Zone, which interacts with Alibaba Cloud infrastructure services, including billing, SLA, monitoring, logging, and web console, etc. The other one is in Public Cloud Zone. All DLA service and the computation nodes are on ECS within its own VPC network. Resource Manager module communicates with ROS, ESS for service provisioning and service online expansion and shrinking. DLA follows the third-party cloud products accessing policy via RAM and STS. The data sources supported include OSS, table store, and RDS. And RDS include many relational databases such as MySQL, SQL Server, and PostgreSQL, etc. So we also support single tunnel VPC, classic IPv4, and the classic IPv6 VIP endpoint for accessing DLA services. Security is always the top priority that user concerns about on the cloud platform. DLA puts the security as the top priority during the whole product's design and implementation procedure. User relies on cloud account to manage his or her DLA services, including JDBC or ODBC endpoints, and the DLA account. DLA account is the product's own account system, which is decoupled from the Alibaba Cloud account for more secured and flexible reason. Users use DOA account to connect service via JDBC or ODBC, which is the experience almost the same with MySQL. In DOA accounts, user credential can be encrypted via KMS envelope mechanism. As DOA provides access accounts, you can create, grant, revoke, remove account authority, very like the experience within MySQL. While accessing external data sources, DOA called RAM STS to assume an ARN role with a temporary security token. By the way, RAM is the resource access management. STS is the security token services on Alibaba Cloud. All DOA computation nodes run within VPC network to make sure the network isolation. This is the DOA data flow landscape today on public cloud region. DOA will handle the metadata mapping to data source like OSS, table store, and RDS. You can issue the table joining query, which pulling data from OSS, table store, or RDS, and write the results back to OSS, table store, or RDS. From the computation engine perspective, we have done lots of data source aware optimization. The first one is the OSS select pushdown. OSS select is the OSS CSV file select engine running at the OSS site to do simple CSV file filtering and aggregation. This feature has already been deployed in some China regions and being spread to other worldwide regions in the next few months. DOA can now detect the OSS select capability and push down OSS select request to reduce the data transmitted to DOA. As we monitored, the TBCH workload query latency can be optimized with 60% to 10 times. The second one is adaptive splitting. When DOA reads data splits from OSS, the split size can be adaptively adjusted to get well balanced to achieve a better data transmission performance in the parallel pipeline. This has got 2 times performance optimization in average in the production environment. For the table store data source, we have deployed an optimized version of API protocol to do row columnar compression and the split rearrangement for the scenario of DOA querying table store data. This has got about 10 times performance optimization in average in the production environment. For the RDS relational database, if the table has auto-increment key, DOA can do key range-based splitting to enable the query parallelism against a single table. This has got about 2 times performance optimization in average in the production environment. This chart, as mentioned before, DOA can now detect the OSS select capability and push down OSS select request to reduce the data transmitted to DOA. We show that TBCH workload query latency can be optimized with 60% to 10 times. As OSS is a main product in a data lake storage scenario, now DOA can directly query extensive data formats on OSS. JSON, text, Parquet, and ORC are hotly used. As JSON and text are usually the raw data or application data generated by the application directly, CSV, TSV, or log file are all the text formats. Parquet, ORC are well compressed for embed data and OLAP schema analytics, respectively. DOA can well utilize the statistic meta built in Parquet and ORC to speed up querying. DOA can also support data in Avro and RC file format. DBS is the database backup service on Alibaba Cloud. Since DBS supports backup image persisted on OSS in Parquet or JSON format, you can use the DOA to query database backup image very conveniently. DBS plus DOA can provide you the extreme experience of database backup data analysis on the cloud. You can even do the historical data analysis directly using DBS plus DOA without restoring image back. Or you can analyze archived image data very quickly and do the fast image restoring as business needs. As you can see in this chart, DLA is now available in 4 regions in China, and also in Singapore and London regions, and is coming soon in US West region.
Okay, thanks a lot, Junlan, for doing the deep dive from a technical perspective. Now let us spend a couple of minutes to look at a live demo that we prepared for you guys to truly understand how DLA works, and from a user perspective, how you can interactively send queries to DLA service and get the results back in a matter of seconds. Now let's zoom in here and open this. This is my Alibaba Cloud international website. So I can log into this website using my Alibaba Cloud account. Now when I sign in now, remember that this is the major account, right? So per each enterprise at a company level, I have just one major account which has all the administrative privileges. And under this account, I, as an admin user, I will be able to create multiple child accounts, and I can create roles and policies and permissions and assign those policies and permissions to my child accounts, right, to my sub accounts. And I can associate those sub accounts to different services, right, even to different DLA regions. So I have all that capabilities. At this point, let's look at, for example, go to the products and browse analytics and big data section, and this is where you can see data lake analytics. At this point, you can click the DLA console, and this brings me to the console interface where I can configure my DLA service. So there's a couple of options. Let's go through these options. So let's look at this DLA console interface. There's a couple of options we can go through on the user interface. So for example, there's an option to reset your password. I got a couple of options here. I can choose whether or not to use the key management service, right, the KMS service. Now basically this allows the system to automatically generate a private and public key pair, and we can leverage those key pairs to encrypt my user credentials. So when I send my login information to the backend service, all the communications are encrypted using that key. I can also choose to use a system-generated password. If not, I can put in my own password. But in any case, once I click confirm, I'll be able to reset my password and find out my new password and credentials under the messages. Another option here is to deactivate DLA service in this particular region. So that'll terminate my DLA service and terminate all of my associated child accounts under that region. And I can also click how to use DLA, and this allows me to open the documentations, right? So I can see the JDBC connectivity, the frequent asked questions, right? The best practice, the quick start, the pricing information, the product introduction information, all the details, right? It's a very handy documentation site. So when I click this endpoint, I'll be able to create the connection endpoint using either a classic network or a virtual network, depends on what I need at that point. So I'm not going to create a new endpoint, just to use a previous endpoint that I created before. So let's show the endpoint connectivity information. Now with that connection string, I'll be able to connect to that endpoint. I'll just click this log on to DMS console, and that should brings up this user interface for me to start querying my data. On the left-hand side, I can see a bunch of schema objects that are mapping to different storage options. So for example, this one is mapping to a select OSS file, actually a bunch of OSS files, right? It's mapping to a particular folder in OSS. And this one, for example, it's actually mapping to a table store instance. Now what I can do here is, let's see, I'm gonna open this as my OSS console, and in this particular OSS instance, I got a whole bunch of data sets, and all these data sets are TBCH data sets, which are basically created for benchmarking purposes. I got a 100 gigabyte data set, a 10 gigabyte data set, and open that. I can see all these are CSV files. I got a customer CSV file, line item CSV file, nation file, orders file. Open that, and there's a bunch of tables. So what I can do is, using the DLA user interface, I wanted to create an external table mapping to the orders dataset in OSS and be able to query that dataset using this user interface. So what I can do is, I'm going to create an external table first. Let's select the corresponding database, which is the TPCH 100 gigabyte. I'm going to run that. Run this query, execute that query. The command is successfully executed. And I can see this orders table being created. And this is actually pointing to this particular folder in OSS. Now I can start querying data from that the orders table again in DLA. Let's open the SQL window, run that. Let's format this query so we can see more details. So actually it's more, I don't know what is that. So it is more complex, right? I'm actually not only pulling data from the orders table, but also joining the results with data that I pulled from some other OSS files. When I execute this query, I have two options. I can either use synchronized execution or asynchronized execution. If I choose to use asynchronized execution, forgot to choose the correct database. It is 100 gigabyte. Now, if I select to use async, what's wrong here? I don't know. Let me see. This one, date. Actually, that is the correct database. So if I run that, there's a syntax error. Okay, sorry. So if I run that, that'll allow me to pull data out of all those OSS files and join the results. At this point, because I'm using the asynchronized execution, I'm not gonna wait on the front end. I'll just have this task ID returned from the query, and I can leverage that task ID to check the status of execution. Once I'm done with the query execution, I can go back to OSS and check the results, because the query results are automatically stored in a separate OSS folder. And each folder is mapping to a particular region. I'm looking for the Hangzhou region. Over here, I can see the DLA results, right? So we automatically save the results in this folder, making sure that you have paid for the SQL queries. You're not going to lose your results. The results are always persistent in OSS. So I can see the results from September, from August, from October, and November. I can always go back and check the results. So that was a very quick demo to show that this is how you can get the results from OSS. Now next, let's see what if I want to get results from a, for example, table store instance, right? So I'm gonna run this SQL query. I'm pulling data out of a table store instance, which is, this is my table store instance. So instance right here, I want to get the results from the same table, but in table store. Actually the same file, but stored in table store. So let me see. This is my table store instance. I've got all these tables. So choose that database and run this query. I'm going to use synchronized execution just to show you the difference between synchronized and asynchronized executions. This is probably going to take some time because we're pulling data out of table store. All right, now the results are back. I can see I'm pulling data now directly from table store. So what I can do furthermore is I want to show you guys the joint analysis across OSS and table store. So how can I do that? What I can do is I can go to table store and I can create a new table over here. So let's say, for example, I'm going to create a nation table. Let's call it nation, maybe backup number 1. And I'll use a primary key in that table because it's a key value pair, so I have to define a key. And I can see that backup 1 table being created, right? Back to my DLA console, open a new window. So now I'm gonna create an external table in my DLA mapping to that particular table that we just created in table store, right? Backup underscore 1. I'll go to the table store instance and run that query. And now if I open that instance, I'll be able to see the new table created. It's over here, right? The backup 1 table, and open new window. And if I select star from that nation backup 1 table, I'm expecting no result because it's an empty table for now. I run that. I don't see any results, so that's perfectly fine. And now I wanted to pull some data out of an OSS file and ingest the results into the table store instance and see what I can get out of that. Open a new SQL window and run that. So as you can see, I am trying to insert into the nation backup 1 table by pulling data out of this TPCH OSS dataset, right? If I run that, pulling data out of OSS and ingest into table store. So now I go back and run this query. I can see results, right? So these are the data sets, data points that I just inserted into the table store instance. And that's a pretty quick demo that we just did as part of this webinar. So at this point, I'm done with all that. If you have any questions, Julan and I will be happy to address all the questions from you guys. And thanks for watching the demo and showing up and see the slides.
All right, so let me pull out the questions. The first one I got is, how does DLA compare to the competitive product on the market? So really, that's a multi-dimensional question. We can really compare those options from different aspects. So for example, comparing to AWS Athena, we support more data formats and more types of data sources. But for the sake of time, let me just quickly answer that question from a performance perspective, because that's important. So eventually, we tested 20-second TPCH queries in production environment using Alibaba DLA, using AWS Athena, and using Google BigQuery external table. Now we're saying external table specifically because when you use the internal table, you can do all kinds of performance optimization, and that's essentially a different type of use case. So let's focus on the external table use case. And for those of you who don't know about TPCH, it's a standard performance benchmarking mechanism in the industry. You can think of like a bunch of relatively complex SQL queries, and there's a bunch of table joins and scans in those queries. And we compared the performance between the 3 products, right? Athena, Google BigQuery, and DLA for total data volume around 1 terabyte. The result is, using DLA, the performance for those 22 TPCH queries varies from a couple of seconds to tens of seconds. And if you calculate the average performance of all the 22 TPCH queries, DLA runs about 10 to 20% faster than Athena and BigQuery, external table specifically. So at a high level, we say for TB scale, for TB level scans and queries, DLA supports online processing. You can get your results back in a matter of seconds or tens of seconds. So that's one question. And we got a question about the DLA service availability in regions like Hong Kong and Germany. Well, the answer is DLA is not yet available in those two regions specifically, but available in regions that are very close. So for example, in Singapore, and that's close to Hong Kong, and also available in UK, and that's close to Germany. The idea is, well, DLA can query the storage service in the same region, no matter where the user is. So for example, you live in Hong Kong and you have your OSS in Singapore, so you can use a Singapore DLA to query that OSS instance. And there's no delay, right? Because the services, OSS service and DLA service are co-located in the same region. Network only becomes a bottleneck when you try to upload data from Hong Kong to Singapore OSS. So there's a delay for that. And to address that problem, we plan to open DLA services gradually in all the regions. But from a user perspective, if you have immediate demand and you have a very low tolerance for a cross-region slow performance, definitely talk to our sales team and we can talk about the prioritization to open the services in your region. That's not a problem.
Okay, let me see. There is another question about, is there any limitation or restriction of the DLA service? Okay, that's a very good question. And actually, yes, we have some service limitation currently for the DLA on the Alibaba public clouds. That is that the DLA is a serverless and multi-tenancy mode. So we have some limitation for a single user that how he can access the DLA service. One limitation I need to mention that is that currently the maximum JDBC connection or ODBC connection to the DLA service for a single Alibaba Cloud accounts is 10 JDBC connection simultaneously. And another limitation is that the JDBC connection frequency currently we limit it to the one single IP from the client is the 60. Sorry, is the 100 times that the single IP can connect to the DLA service in a time duration of 60 seconds. Another limitation is that the maximum schema that the user can create. Currently, the default number is 100. And another limitation is that how many columns that a single table can create. That is 999 columns. And another limitation is that how many tables that a single user can create on a single schema. The default value is 4096. Okay, so if the user has some special requirement that he can allow more IP connection at the same time, or the more schema or tables he need to create, he can submit the tickets to the ticket system, and we can set the user configuration at the backend to service the customer.
Okay. Another question about our pricing model. So in fact, DLA has been available for public beta testing for free for a couple of weeks. And we just announced the GA version yesterday. So here's our pricing model. We charge the price based on the scanned data volume. Specifically, we charge $4 per terabyte. And that's 20% cheaper than Athena and BigQuery external table case. And we have a follow-on pricing question with a focus on query complexity. So the question is, if I run a query with a simple calculation but very heavy scan, is the price going to be the same? Well, the answer is yes for now. We do not account for complexity in addition to the scan data volume, because ultimately we like to provide a simple and intuitive pricing model, right? Easy to interpret from a user perspective. And we found out that when we take into consideration of the query complexity factor, it turns out the pricing becomes super complex. So from a user perspective, it becomes very, very hard to figure out how the pricing number came out. So that's why we like to keep the pricing model simple for now. And moving forward, we continuously invest in query optimization. If we account for complexity in pricing, the price becomes unstable, right? You run the same query now, and you run the query again in 2 months, you might end up paying a different price because of the query optimization. And that's again very confusing from a user perspective. So because of all that, we only take into consideration the scanned data volume for now, and we might account for complexity down the road if we end up coming up with a more intuitive model. And we have a question about the DLA SQL syntax compatibility. Well, the answer is DLA is fully compatible with MySQL syntax, which means from user perspective, if you are already familiar with MySQL syntax, the learning curve becomes extremely low for you. And additionally, for any SQL client, such as MySQL client, or some other BI tools and BI products, as long as they can support MySQL syntax, you can connect those tools and products natively to DLA, and that's super convenient. So looks like that's all the questions we got so far. For any further questions, definitely feel free to reach out to me or Junlan on LinkedIn, or just simply send us an email. The recording will be available on the website tomorrow. And also, most importantly, I want to mention that if you want to give it a shot and try DLA for free, you can scan up to 50 terabyte of data for free from now to December 15th. So definitely open the product page on alibabacloud.com and see DLA in actions. Thanks for attending the webinar. I look forward to talking to you guys in the future.